Right, so hello everyone, and welcome to our last round of panels for today. This is the Geospatial Techniques and Technology Showcase, and so I think we'll have a lot of interesting things to look at. We will be recording the first presentation, but not the second one. So, to begin with, the first presenter is Madeline Wrable. She'll be doing everything imagery at Esri. So that sounds like a nice, small, limited topic. So I'll let you go ahead and take away. Thank you.
Thanks so much, Ryan. Let me get my screen up. Sorry, so used to Teams. All right. Can you guys hear me all right before I move you off? Perfect. Thank you.
Yep.
Okay. Whoops. Wrong screen. We're going to try that one more time. I forgot which screen I moved so I'd have the best internet access for you guys, and I'm rearranging. Okay, can you guys see that all right? Awesome. Okay, so already lost 2 minutes. So yes, I'm trying to cover way too much in way too little time, but I figure I would help explain it with kind of my background. So I too have been in academia. I've been in it for about 10 years now. So my background was not always working for Esri. I actually took my first GIS, remote sensing and statistics class ever in graduate school for my master's. Absolutely adored all of those technologies. And then I became a lab assistant and a teaching assistant for those classes. And then right about that same time, or a few years later, MIT was actually hiring for their first GIS specialist. And to be honest, a lot of the job application was what I was doing as a student worker and with all of these workshops and tutorials that I was helping to write and put on. And so from there, I became the GIS specialist for the next 5.5 years. And I absolutely had a blast there. I mean, the libraries are very underutilized. I didn't use them as a student. They're filled with incredible people who are very knowledgeable, actually. And I taught a ton of workshops while there. I just wanted to share that, GIS remote sensing, spatial statistics, even 3D modeling, game engines, statistics in general. I mean, when you do research, you really weave in and out of all of these different technologies. And so I really have a passion for showing people that these technologies are easy, great to use, and you can do amazing research with them. So what I hoped for today for you guys is that now that I work for Esri as a solution engineer in imagery and remote sensing, I was really hoping to kind of give you a taste for what is imagery like at Esri, and from a very broad perspective. So with now only about 15 minutes to share, it's going to be kind of rapid fire. I want to share these slides with you. There's a lot of hidden slides in here with additional information, but I just want to give you kind of a taste for it. And so let's get started. Okay, so this slide is commonly used at Esri to kind of describe our entire imagery system, but all that you really need to care about it is that we consider imagery to be separated into 5 different capabilities. And so I'm going to go a little bit through each of them, starting with content. And so really the first thing that you need to know is that you're at an absolute wonderful time for remote sensing. There's an absolute explosion of platforms, whether this be CCTV, the Google car driving around, drones, satellites, crewed aircraft, even the camera on our phones. There's so much images and imagery being acquired all the time in different formats. There's a lot of types of imagery. There's visible, imagery that looks just like it would to our human eye. But as we're starting and have understood for a while now, there's a lot more to be seen beyond what just a human can see. There's infrared, there's ultraviolet, there's all of these bands and wavelengths that we can detect that help us understand our world better, that satellite, or not just satellite, but remote sensing and imagery can really help us understand. So there's multispectral. There's even finer band divisions. They're hyperspectral. There's multidimensional. This is not just space and time. This is also additional variables that you can map in other dimensions. There's many different types of imagery. There's video, there's radar and SAR, and there's even LiDAR. Now, where can you find all this data? Well, it's usually separated into different bins. So you have data that's user data. You can store your own imagery on premise or in the cloud. Also, Esri provides a lot of imagery data sets through their ArcGIS Living Atlas of the world. They also will talk a little bit about deep learning and what that is, and what are these pre-trained models and tools that the Living Atlas also provides. But you might be more familiar with commercial data. You know, if you can get a grant, if you can get your advisor to approve, if it's worth it, you know, you might want to purchase some commercial data that's usually of a higher resolution or value to your research. But really, I would argue and stand by that a lot of the backbone of research is done upon open, freely available imagery data. So that could be, in terms of satellite data, that could be your Landsat, your MODIS, your Sentinel. It's what NASA, you know, and other places collect and provide, USGS. It's a lot of these free data really provides a strong background for research in general. Now, with kind of the general content out of the way, I want to talk about the second bubble above it, which is a different sort of content. ArcGIS at Esri, we are coining the term reality mapping. So this is really additional foundational content that you can create, but it's through the technology of photogrammetry. What the heck is photogrammetry? Basically, it's technology that you can take a bunch of pictures of things and you can turn them into all these different wonderful products that are very helpful imagery products to use. Some of them are listed right there. Most often, this can be done by a handheld camera, but usually you want to let a robot be a robot and let the drone or the satellite or the aircraft, you know, collect the data with enough overlap and certain standards so that it can really stitch the images together to produce nice outputs. But this is kind of the bubble of all of the photogrammetry created content. Now, what does this look like at Esri? Esri has the ArcGIS Reality Suite. So we have about 4 different photogrammetry products, and you can kind of get the hint that the more drone-focused ones are on the left, and the more aircraft and satellite are on the right. But what they have in common is it's the same photogrammetry engine, the same one being used in all the products. Now, what are these outputs? That's kind of the whole point of putting this into another content bubble. Well, I'm going to briefly talk about the 4 main ones that all of them produce are pretty awesome. So orthomosaics kind of just look like a pretty picture from the top down. It looks like, great, another base map image that's a bit more updated because I have control over the drone more than a satellite. What true orthomosaics are very powerful in is that they're not only a top-down view, but all of the distortion of however the sensor to collect it, no matter what angle or direction it's capturing it, it's going to capture the edges, the sides of buildings, and you don't really want that in a top-down view. So the photogrammetry software has actually corrected all those distortions that when you're looking at it, it's a straight top-down view from any point on it. Why do we care so much about this? Well, because when you have this picture, this image, you might want to trace it. You might want to digitize features out of it. Really common ones like this is showing are building outlines. And when you trace them, you want to make sure that they're very accurate so that the area, the length, the width, any sort of measurement that you want to take off this is accurate. Why is this important? It plays well with your other vector data. It can play well with building indoor modeling data that previously was kind of its own, you know, realm of its own. But because the drone data is so accurate, you can use it with all sorts of other data sets. Now, moving into the next one, we have digital elevation models. These are like surfaces. You know, you can have a digital terrain model. That's kind of what is the raster, the surface on the ground of an area. And then you can have a surface model. It can be the ground, oh, then a tree, back to the ground, oh, then a building. And what's nice is that if you subtract the surface model from the ground, you actually get the height. And so you get a third raster that's all of the height values. And if you use that height raster back with that digitized buildings that you created before, you can extrude them using the heights that you now know, and you make a pseudo 3D world. So that's why they call it 2.5D, because you're just kind of getting blocky outputs of whatever you're digitizing and have extruded by that height. And in the real world, we know that the edges of buildings have information, they have facades, they have, you know, additional information to them. But if you just want to kind of do a pseudo 3D, you actually can just with 2.5D, 2D and 2.5D products, which, fun fact, educational licenses, you all should have access to Drone to Map standard, which will let you do all of that. Now, if you want Drone to Map advanced or site scans, kind of a cloud processing, so you can do multiple projects at once, they're very elastic in the cloud, then you'll get into our 3D products. 3D products are wonderful in their own right. If you're looking at a point cloud, you might, like me for a very long time, be like, you know, they're cool. They're kind of lumpy. They're kind of bumpy. They're kind of hard to look at. How do I use it? The thing about a point cloud is it's going to be the most accurate representation of the 3D world. We're getting the sides of the buildings and all of the lumps and bumps of real life. The other thing is, if you walked into a construction site and you wanted to measure or get the volume of a pile of dirt, and I'm not talking a perfect conical pile of dirt that you could do some mathematical calculation, I'm talking about the real world. How the heck do you calculate the volumes of things? Point clouds. You fly a drone, and not only do you have very accurate top-down views, if you create point clouds, you can do volumetric analysis of anything that it captures. So huge leaps and bounds in efficiency and just analysis. And if you want to start to digitize the world around you or your research site, drones are an excellent option. Now, 3D meshes look more accurate, but a mesh has actually interpolated. It wants to fill in all the gaps, while a point cloud is really going to show you if your drone flew too high and you missed kind of some lower spots, let's say. So a 3D mesh might look more accurate, but that's just because it has all of the true color, you know, what the pictures, it would actually look like in real life. That color has been applied back to the interpolated model. So meshes are great for other things. They're great in game engines. You know, any game that you've played is probably using a realistic 3D mesh. Now, moving on. We've learned a bit about all these. These are some cool things that can be acquired through photogrammetry and the reality mapping options. They differ in that there's quite a lot of platforms. So we have our 2 drone offerings, and then we have the scale of the project that you might want to use them on. Again, just warning, I'm going quick, I'm sorry. So going into data management, we're really going to skim the surface on this, but I want to make the point that there's such an explosion of imagery that you really need a place that you can access the data. You can sort all of these images, you can query them, you can search for what you care about using their different metadata. You know, new satellites are being launched every day. Old ones are getting kind of refurbished. That's a lot of different data sets and types and sensors and things to keep track of and make play well and be able to work together. So there's a lot to this. There's processing, analyzing a bit, even, of course, distributing and sharing out. Maybe even as image services, so you don't have to keep transferring the whole heavy imagery data set. There's many ways that we deploy here at Esri, and you're probably familiar with some of them, but I think it's important to just get a refresher. So we, of course, have desktop. That's kind of our full analytical, you know, full analytical horsepower. You might want to add in the extensions image analyst or spatial analyst to work with imagery. Now we have ArcGIS Online if you'd rather work kind of on the web. And with ArcGIS image for ArcGIS Online. You can upload, host your own imagery. You can even analyze in it, share out as tiled or dynamic imagery as well. With managed SAS, if you're working with even greater amounts of imagery, you might want Esri to kind of manage a server for you because you might be new to it, like I would be. And another benefit of Image Dedicated is you can spin up virtual pro machines. And so that's getting the full analytical power of the desktop version, but in the cloud. And you can even stand them up through your cloud provider of choice in any region. Lastly, if you want full customization, that's when people get into enterprise and they have their own image servers and they can kind of customize as they'd like. These are some of those photogrammetry and kind of some new products as well that are coming out and kind of where they land in terms of these deployment options. And then this is probably my longest section and I'm really creeping in on the end of it. So I might go a little quicker, but this is usually how we present on image analysis. And yes, the middle circle tells you a lot of cool things that you can do, but I really want to take a moment to remind you that imagery are rasters. You know, they're not vectors that are stored as coordinates of points, lines, or polygons. They're actually a very different data type that's stored as rows and columns in a matrix that usually only represent one variable at a time. And a lot of pictures and even scan maps are rasters. There's also different resolutions. I'm going to really go quick through these, but I am going to share the slides. There's different types of resolution. So there's spatial, spectral, temporal, and radiometric. You can think that this one is kind of stretches. And so really when you're doing analysis, it falls into two different groups. You might want to enhance an image. So you might want to apply a filter. We all know from Instagram, you might want to sharpen it, blur it, change the color. But there's also many other things you can do to enhance this type of data. The other big thing that people fall into wanting to do is to extract information from it. So they might run an indice on it. You know, you've heard of NDVI. That enhances, well, might fall into the enhancement, the vegetation or soil moisture or urban development. We've actually been doing machine learning all this time if you've ever done unsupervised or supervised classification. But now with the explosion of deep learning, it kind of does it for you and you can tweak them. So some of the examples of what deep learning or classification can look like are any of these applications, which can be sorted into these categories by pixel, object, segmentation, or just regular classification. And even however you detect them, there's patterns that can be recognized and predictions that can even be made. All of this from imagery. There's a lot of different pre-trained models that are available in the Living Atlas that work on a lot of different types of imagery, even text. There's deep learning models for that. But we're not talking about that. We're talking about rasters. And raster tools can even be local, focal, the neighborhood. It can be zonal, like the census tract, and it can be global, like an elevation service. You might want to find the highest point or the lowest point. So it's going to need to look at every pixel to determine that.
Thanks. In the interest of just having some time for questions.
Oh, I don't have any time for questions. I think we started 2 minutes after. Is it okay if I go for the last 3 minutes?
All right, we can have 2 more minutes.
Okay. So with image analysis, there's geoprocessing, which creates new tools, raster functions, which perform on the fly, and there's absolute tons. And then there's, of course, programming that you can really scale things. Coming into the finish line, we have visualization. And so what's the whole point of visualization? There's a lot of web apps and maps, story maps, Excalibur, Map Viewer Classic, Experience Builder. The point of them is that you want to store your imagery once and probably serve it up as an image service you can easily share with others through any of these apps that are the most appropriate for your use. One really great demo that we don't have time to do, but I can share out the slides, which will have the link, is the Landsat Explorer. If you're brand new to imagery, this is a great place, which is really quick to show you different bands, different locations. it's really awesome to play around in that to get a feel for imagery. And then lastly, just kind of as a big picture, we've kind of started up here with content. It can come from a lot of different sources to get imagery. We've talked about the photogrammetry, the ArcGIS Reality Suite. There's many different deployment options that can hold your data or photogrammetry outputs. There's a lot of ArcGIS image that can help you kind of host and create image services depending on your deployment. There are a ton of web apps and maps and things that can help you share out it. And of course, there are millions of applications of imagery. So that is all I have. But I just hope that in this very rushed, no time for questions, I'm so sorry, thing, you got a feel for like, what is imagery at Esri more than the kind of static, stuffy way. So I hope you have a better feel for kind of imagery at Esri. Thank you.
Thank you very much. Yes, lots of pictures, lots of imagery.
Yeah,
so,
very fast.
all right, we will.
Yeah, sure. So the reason why I asked Katrina about the access issue, because I found you are a UCLA students. I thought this kind of related to what I want to discuss later in my presentation. So I want to let people know that we have so as an UCLA affiliated students, you have access to all suites, Esri suites of products, either online or pro. But if your team is an international team, have people from other universities, so that may be a problem. But I want to let you know you have access to all Esri suites for now. So which is related to what am I gonna present now. Okay, so for my presentation, so I want to talk about the SSO access to ArcGIS Online across the entire campus for UCLA. So I may not take the rest of the 15 minutes or 20 minutes. I will walk you through how can UCLA affiliated people get access to ArcGIS Online and ArcGIS Pro and the other products. So this presentation is mainly targeted for UCLA community, but you are interested in these ArcGIS Pro and Esri suite software, you may have some information out of my presentation as well. So now we'll get started. Let's move to the next one. So we have a homepage of ArcGIS Online, and starting from this January 2023, we switched the login access from manually creating accounts to SSO, which means so all UCLA affiliated people who have a UCLA account can have access to ArcGIS Online. So you don't need to send me email, ask me to create an account. So once you have your UCLA account and password, you will be able to get access to ArcGIS Online. And a very important product of ArcGIS, like Esri product is ArcGIS Pro. It is desktop version software. So previous is ArcGIS ArcMap, now it's ArcGIS Pro. So compared with the online version, it has more powerful functions and can be used by the community. And also for some like basic analysis, for example, the intersection, the cut, the overlay, etc. These functions, you don't need to cost the credits online. So when you do these functions online, you will have the credits. But if you do it in ArcGIS Pro, it doesn't cost you any credits. So for UCLA community, we have a LibGuide, and this is the link of the LibGuide. In the LibGuide, this gives you an introduction about how to download ArcGIS Pro and what software or functions that are available for the community. So if you have the public account and also UCLA account, how can you merge this the content in from these two accounts? So if you're gonna leave UCLA, for example, you graduate, so how can you keep your content and how can you save your content? Or in the future, if you want to move your content from your UCLA account to your personal account. So these have a very detailed instruction about how this can be done. And these links are here. So I'm going to go through this LibGuide also later. And I also want to show you how to use Citrix, for example, for people who have Mac but doesn't have a PC. So who also want to use ArcGIS Pro. And you can take advantage of the Citrix environment, the service offered by the library. I'm going to show you how to get access to that as well. And I think these are the slides I want to discuss, but I want to give you my contact information first here. Okay, I'm going to show you how to get access to Citrix and also ArcGIS Pro. So this is where I'm from. So I'm from Data Science Center. So I'm a special data science librarian. So I'm here specifically to support any geospatial research projects related things. So if you have, for example, want to access ArcGIS Pro, you want to learn some ArcGIS or geospatial analysis skills, or you want to find some educational instructions or materials, feel free to send an email to datasciencegis.ucla.edu, or you can search UCLA Data Science Center, so you can find our website and make appointments with us. So this is about my information. And next, I'm going to show you how to use SSO to log in ArcGIS Online. So this is UCLA's ArcGIS Online homepage. You click sign in and use UCLA SSO. And you type in your account and password. Okay. And you're gonna get a push. Let me click approve, then says, and you logged in through SSO. And there are several tabs here. So if you click this tab, it will direct you to a part of this LibGuide. So this is the home of the LibGuide. So it shows the transfer to another UCLA account, transfer to non-UCLA account. And also, so these are instructions how use the ArcGIS Online Assistant to transfer a content from one account to another account. And also they have an API for Python, which can accelerate the process of transferring. So I'll have ArcGIS account, how can you get access to that? ArcGIS Pro, how can you download ArcGIS Pro from ArcGIS Online? I will show you shortly. And several tutorials and also GIS support. So if you want to learn more about ArcGIS or any geospatial related things, out of more than what the LibGuide provides you, you can make an appointment with Data Science Center. This is where I'm from. And you can click geospatial analysis and GIS support and find available time, and we can meet together. And let me see, go back, go to ArcGIS Online. And the other tabs of the tabs listed here are directed to the LibGuide I just showed you. So it's about covers other information. So next, I want to show you how you can download ArcGIS Pro. You click your account and go to My Settings. And then there's licenses. There's Download ArcGIS Pro. You click it. So it gives you the latest version of ArcGIS Pro in different languages. So 3.2 is the latest one. So for the online version, it always gives you latest version. But if you, for example, you work with 3.0 or 3.1 with a previous project, you want to have the old version rather than the new version. So you can send us an email and request for that. So we have access to the old version, which you can't have access to through ArcGIS Online. So tell us, I want old version. Can you provide it to me? So we can log in from admin and find the old version for you. Okay. And next, I want to show you how can you, so I downloaded it and I installed on my PC and I want to open it. So previously we had a 3.1 version. So we had some issues log in using SSO when we want to log in ArcGIS Pro. But for now, it's updated to the 3.2. So the problem should be resolved. So I show you, you can, so for the SSO login, you need to select the ArcGIS organization URL. You tap in GIS, UCLA, and then continue. And I'm gonna give you, and I'm gonna sign in, another push, the approve. Okay, open ArcGIS Pro. See, still loading. Okay, it's loading here. Okay, now I'm signed in, so I can open it and start a map and work on it. So this is from PC. Because I use PC, so I can install ArcGIS Pro on my local device. So that's how I access it. So I know several people had this login problem with the version 3.1, and I had no problem logging, but several people has. So if you have this problem using 3.2, so send us email, tell us, we have trouble logging. Can you help us? So you can send your email to datascience+gis@ucla.edu. So this is from my PC. Let me show you how to work it. How to open ArcGIS Pro through Citrix. So first, I want to show you how to download a Citrix Workspace app. There is a page that describes how to download it for different devices. So for Mac and Windows and Linux, there are different steps. So you can refer to this page. And this page is also in the LibGuide. There is, for example, ArcGIS Pro here. So using ArcGIS Pro on click virtual desktop. So it is Citrix. Okay, so there's instruction how to download that. So to access the Citrix environment, so once you install Citrix, you can find it from this menu, and there's Citrix here. You can click it, it opens this first. And then I click Software Plus, it gives me this window. You see log on, see if I can log on. So to connect to Citrix environment, you need to log in VPN first. Otherwise, you won't be able to use it. See. Give me another push. Supposed to give me another push. Let's see. Here. Okay, let's move it here. Connect in. Let's see. Sometimes it's fast, sometimes it's slow. Okay, this time it's fast. Awesome. Preparing for me, the desktop. Okay. So for the Citrix virtual desktop, I believe, if I remember correctly, the data on the virtual machine will be wiped out every 6 hours. So if you want to work in the virtual desktop, so remember to save your data frequently. Kind of slow. I just noticed I'm out of time. Okay,
No, you still have about two minutes left.
Okay, I'm not gonna be done. So it's a similar process. So remember to save your data often and go to ArcGIS and ArcGIS Pro. It should be a similar process, but for some people it's not that easy. Um, give some barriers. So, okay, see. So, well, we are waiting. Any questions so far? Oh, okay. The same. I'm gonna click the organization's URL. It's just UCLA, and then continue. And then SSO, and the same. Okay. Okay, it works with my account. So again, if you have trouble logging, feel free to reach out and send an email to the email address. Let me show the email address again. Because for me, I never had the trouble logging, but I got so many emails telling me, I can't log in via Citrix. So hopefully this this problem was resolved by the new version, but I can't guarantee. So if you have any question accessing ArcGIS Pro through SSO, feel free to reach out. Okay, so that's all I want to cover. Thank you.
Thank you. And that is actually a way to get Esri products on a Mac, kind of. So you kind of have access to it.
Yeah.
Any questions? Oh, one thing I would like to just mention, say one, and I've had people ask me about this, and I think you're more of a trustworthy source of it than I am. People are sometimes concerned about running out like credit hours or that kind of thing through Esri. Can you just tell them basically how easy it is for us to up that allocation if needed?
Um, so by default, we'll allocate 1,000 credit to each account. If you don't do like too much work using it, it's gonna be okay. But if you need more credits, so once you're gonna run out of it, the system gonna trigger an email. So I'm gonna got an email so I can update the credits for you. Or if you think I can wait, just send me email so I can do it manually for you. But 1,000 is for most of time I can see is enough for most of the analysis, because for some basic one, as I just mentioned, you don't need to cost any credits. Okay. Yeah. Thank you for bringing this up, Ryan.
Yeah, it's a concern I've heard from some people, but generally you will not hit a wall on usage. And if you do, we can help you get around that and keep doing your work.
Yes.
All right. Any questions or comments? No. Well, again, thank you. It's really great to be able to actually do single sign-on, which I think is misnamed. It should be multiple sign-on all the time, like 14 times a day. If
Yeah.
you're familiar with how it works at UCLA.
Yeah.
But yes, thank you very much for a great panel. Thank you, presenters. This is our penultimate day for GIS week, and then tomorrow will be the last GIS week presentations. So enjoy those. Um, we'll have other MCs because I will actually be giving a workshop on using, of all things, high performance computing and digital elevation maps. So there's all kinds of GIS stuff going on in all of the campuses. So thank you again, everybody, and enjoy your day, and we'll see you tomorrow for more GISing.
Yeah, thank you. Thank you for organizing.